So when I started designing for 3D printing, I didn't realize that there was one skill that was critical for me to get a good grasp of, to make cool projects and make models really well. That skill was sketching. And depending on the type of software that you're using, it's pretty much the same. So the principles that we're about to go through will probably apply to the vast majority of software, but we're going to use Fusion 360 as an example. So this is 5-Minute Fridays, so let's put 5 minutes on the clock and let's get into this. So once you're in Fusion 360, you're going to want to get into the sketching workspace so we can have a look around and start our project. To do that, we need to look at the ribbon at the top of Fusion 360 and click the Create Sketch icon. So we're then presented with 3 planes that we can apply our sketch to. So the blue represents the Z-axis, the green represents the Y-axis, and the red represents the X-axis. So you can put a plane looking top down, face on, or to the side, depending on what your project requires. For this example, we're going to click on the bottom face. And we're now presented with a new ribbon at the top, and the ribbon is broken down into 4 main areas, but I'm going to restrict this to 3 for simplicity. So the first section is the Create section, and this is where you find the majority of your sketch tools. So this is where we would find a line tool if we need to draw a line, a rectangle tool, a circle tool, a spline, and all of the other tools that are associated with actual sketch elements. The modify section is where we come to do exactly that, modify. This is a modifier that we can apply to a sketch object, and that could be anything from cutting up a line, creating an outline, putting a fillet on a right-angled corner. So there's a number of different modification tools that we have available to us. The last section I'm going to be talking about is constraints. Now, constraints are ways that we can tie down our sketch so that it is fully defined. So for example, you can define something as vertical or horizontal. You can define something as parallel. You can define something as right angles. So we're going to model a few different things to demonstrate the tools that are used in sketching and how you can generate quite complex geometry from simplistic sketches. Now, this is definitely a skill. This is something that needs to be worked on. You're not going to get it right first time. The more you do, the better you get at it. So I'm currently looking about my desk to find something which is relatively simplistic that we can model. What about this? Can I model this? I want something fast for the video because it's 5 minutes. 5-Minute Friday. Okay, so I'm going to model this TDS meter. It's a measuring device for hydroponics. Maybe I want to make a plastic case that this sits into. But in order to get this case made, maybe I want to bring it into CAD and then model the case off the CAD model maybe. That could be something I want to do. So we're going to take measurements of its dimensions, and then we're going to bring those into the CAD software, and we're going to digitize this external case. We're going to block out the sketch with very primitive shapes, and then we're going to refine it into its final product. The first thing that we need is a rectangle. So I can click the 2-point rectangle tool, and this will allow me to click anywhere in the sketch and drag across to 2 points, and then we have a rectangle. There is other rectangles that you can use, and let's say for example we go into our create rectangle, we got a 3-point or a center rectangle. I very often like to use a center rectangle. I very often like to put my center point of my sketch to be the center point of my object, and that can serve you later on when you're starting to bring things together in an assembly, and it helps orientate things. When you put things off center unintentionally, it can cause some weird things to happen further down the line. So I use the center rectangle, and I've just put a rectangle on the sketch. There's no information about this rectangle, but we can add additional information to it to fully constrain it. Now, it's best practice to fully constrain a sketch, and you know when a sketch is fully constrained when the lines turn black. If they're blue, they have the ability to move in some way, shape, or form. You may want that. You may want to be quick and dirty and just put something in and not fully constrain it. But then again, you may want to lock things down because you don't want other attributes of the sketch to impact that particular element. So to set some constraints, first and foremost, our center of the rectangle is constrained with a coincident. This little dot represents the center point of the box, and it's locked. So if I try and grab this and move it, it won't move because it is locked to the center of my sketch. So using the dimension tool, I can now click each of these lines and put some dimensions in. And we're just going to put some arbitrary dimensions in for right now. Let's grab a digital caliper. A digital caliper is your friend. Okay, so we'll zero out the digital caliper and we have 30 millimeters. Oh, that's handy. So that dimension is already correct. And then we've got 155 in the length. So let's change this to 155, 155, like so. Perfect. So next up, we've got some radiuses on these edges. So one of the things that I made was a set of radius finders. And essentially these are like feeler gauges, I suppose. Each of the external corners has a particular radius, and each of these internal corners have a particular radius. And I can offer this up to an edge, either inside a box, if I'm trying to get the inside the radius of a box, for example, or if I want to offer it to the outside radius, I can quickly find the radius with these radius finders and enter that information directly into the sketch. So I can already see that this is quite a large radius. So I'm using the 9mm to 12mm radius gauge, and I'm going to go around, and I'm going to go around until I find it. It's actually a 9mm radius. Maybe not. Maybe an 8. Let me just double check it's not an 8. So I'll get my 8mm gauge, largest one. It is actually an 8mm radius because I can see that it seals around that edge perfectly. Let's put those radiuses into the sketch. And we're going to use the modify tool, the fillet tool, and I'm going to select the left edge and the bottom line, and the top edge and the right edge. Okay, they're currently set to 5. If I put that to 8 and hit return, so we now have our basic outline of our object, and we can finish this sketch and then go to the create toolbox on the ribbon and choose extrude. So let's take a quick measurement of the thickness, and we're looking at 13.7 millimeters. I'm going to go 13.8, just to round it up to the nearest decimal. 13.8. I could go 14, but it's going to be quite tight on tolerances. So I'm building some tolerances in here for when we make the box later on. So next we got some features on the face of here, and we can repeat the process of sketching, but now I can actually place a sketch on the body itself. So I can click the sketch tool, click the surface I want to put a sketch on. We're now sketching on the top edge of our TDS meter. So I'm gonna quickly just put some lines in here to represent what I'm trying to do. And I made an intentional mistake. I'm gonna make another one. In fact, I'm gonna make 2. And I'm going to demonstrate, we can just do rough sketching and then use the constraints to pull our drawing into some form of accuracy. So with our trusty calipers, let's get and measure where this first line is going to be. So we hit the dimension, or we can press D on the keyboard. I highly recommend getting fluent with your keyboard shortcuts because it will dramatically speed up your modeling capabilities. Regardless of what software you're using, shortcuts are your friend. So we're going to dimension this line and the edge of our meter, and as 21 millimeters. We're going to measure the depth that it goes to the bottom. That's 28 millimeters. So we're going to dimension from there to there, and that's 28. Now we've got a problem. This line isn't perpendicular. It's not, it should be at a right angle, but it isn't. But what we can do, we can use a couple of different constraints to make that perpendicular and correct our very rough sketching mistake. Now to do this, we can use a couple of different tools, 2 of which you could use the perpendicular tool, and you click this bottom edge, there's the reference edge, and then the edge that you want to correct, and it snaps it vertical. So undo that for a moment. We could also use the horizontal vertical tool, and by clicking that, it makes it a vertical. Or we could use the parallel tool, and we could choose this line first and then click this line, and it snaps it parallel. So just because you make a mistake when you're sketching, you can use constraints to pull the accuracy back into your drawing, allowing you to keep moving at pace. So I'm gonna quickly run through this sketch and correct some of the mistakes that I've made. And then we're gonna put in the dimensions of our drawing. You'll notice as our lines are being fully constrained, they are turning black, which is good. Okay, now you'll notice that there's some radiuses here. So again, we're going to use the radius finder, and we're going to offer up the radius to the corner, and we're going to find out what radius it actually is. So I believe it's going to be somewhere in the region of 6, based upon what we saw with the external radiuses. So that's a guess from me. So I'm going to pick up the radius finder. Let's see if I'm right. No, I'm not. Okay, so I am right. I sit corrected. So let's use our fillet tool. We're going to apply the fillet to all of the objects. We're going to finish our sketch, and this time we're going to select these objects and we're going to extrude them down by negative 0.5 millimeters, and we're going to cut into our object, and there we have a very quick model of our TDS meter. Sufficient enough for us to make a model for a case for it, for example. So what if you want to make something which is round? What can you do then? Well, very similarly, we're going to go back into our sketch palette and sketch on the front face. We could use the side face, and we're going to use the center of our sketch to be the bottom and center of this pot of magic goo, right? So what I'm going to do is I'm going to roughly trace out the shape of our bottle, and we're then going to apply some constraints to it to pull it into some accuracy, and then we're going to turn it into a 3D model of this bottle using one sketch and one operation. The fewer operations that you can use to achieve your end goal, it's a simple project with just one item. It's not too much of a problem to have lots of different operations to get there. When you get into a complex project, your timelines, certainly in Fusion 360, your timeline can get incredibly long. And if you have cut corners or you've made some mistakes because you're not proficient in the software, you start to get errors creeping into your timeline and everything starts to collapse. I've got timelines from my early projects which they scroll off the screen when they didn't really need to. And that was just inexperience. Now I try to keep my projects as simplistic and as elegant as I can for my skill level. So I'm going to use the line tool. I'm going to draw what I think is the bottle profile. We're going to come up a little bit. Let's hold the bottle in my hand. It steps in, steps up, it comes back out for the lid. I'm modeling the lid all as one here. I'm not modeling anything in terms of like a removable cap. We've got like this step effect. Okay, so this looks incredibly strange right now. So I'm gonna start using my dimensions and constraints to pull this in, and we can turn this into a accurate 3D model. So the height we've got here is 112 millimeters. So we'll dimension the top and the bottom as 112. Now working from the top down, I'm going to measure the first step. I'm also going to measure the dimension at the top here, the diameter of the cap, and that is 22 millimeters. So I'm actually going to dimension this line 11. That might seem really strange, but it will make sense, trust me. Okay, working from the top down, let's get the next dimension. We have got 26 millimeters. Now, some cool things you can do with dimensions. A dimension here and here. I can type in 26 divided by 2. I can put a formula in here and it will snap into place. So it's really handy if, like me, you know the formula to get what you need. You can't necessarily drive math. This is 28, 13. So that's our cap. And then we have this step in and step out, don't we? Which I've made an error. So I'm going to trim this line away, and I'm going to put in I'll trim 2 lines by just hitting T on the keyboard, I've activated the trim modify tool, and I can now just click here. All right, we got to step in. This is the indent into the cap. And that indent's 3.5 millimeters. So let's dimension that to that. And it is 3.5. Let's get the dimensions of the thickness. It's 1.5. Perfect. And actually I can trim, use the trim tool just to snip away this and snip away that. And I'm going to use the coincident constraint. I want this dot here to be connected to that dot there. So to do that, I can use this coincident. I can select that and I can select that. And there we go. Now it looks a bit weird now. Okay. Now all we need to do is hit the dimensions of the overall bottle, and that is 15. And if I finish my sketch, I've got this sort of profile of the bottle. Now I can use the revolve tool. So I select the sketch that I've just created. Where do I want the axis of revolving? Well, I choose the center line, and I now have my bottle of Magic Goo. So we only use a selection of the tools, so there's a lot more that the software can do. But I would highly recommend using each of the tools available to you in the Sketch Palette to try and find out what they do, how they interact with each other, so you can get a good grasp of them and use them where they're appropriate. So that's a very high-level overview of the tools that are available in Fusion 360. I recommend getting used to using each of the tools and exploring the ones that we haven't discussed to see how they interact with each other. If you like this video, why not consider hitting the subscribe button? And you can also check out one of my other videos just here.